So in this video we're going to look at capacitors in series, how we can work out to simplify them down so that if we've got several capacitors in series, how we can create just one capacitor, and then we'll also tie in with that looking at charge and voltage. So we're dealing with this circuit. We use a similar formula that we use with resistors, except this time round we would use what we would think about using the resistors in parallel formula for capacitors in series. And that sounds a bit gobbledygook. So 1 over C1 plus 1 over C2 plus 1 over C3 is equal to 1 over our capacitance total. So if we do it with this example, then so 1 over our capacitance total equals 1 over 9 farads plus 1 over 18 farads plus 1 over 6 farads. Okay, what does that work out to be? So the same way with our resistors, that we haven't actually worked out what the total capacitance is. We've got 1 over it, so therefore we need to take 1 over our answer. So our capacitance total equals 1 over our answer, so that equals 3 farads. And the same with our resistors, that the total capacitance is going to be no bigger than the smaller size capacitor. So we've got 3 farads, which is smaller than our smaller size one there that we've got. Okay, so there we have it. We can replace those 3 capacitors in series with a single 3 farad capacitor. So let's look at something to do with capacitance, charge and voltage. So we're going to use this formula QVC. So if we know what the total capacitance is, and we know what the voltage on the circuit, then we can look at what the total charge, which is within our bucket. So if we pop that into our formula, then we end up with 3 nines 27 coulombs. Okay. Now, if we look back at our original circuit, we can see that I didn't label it up, so we had 9 volts there. So if we had 9 volts, and the 9 volts that we got is split actually, when we look at it as an individual circuit, across each of these capacitors. So what we can say is that each capacitor holds 27 coulombs of charge, so therefore then we can work out what the voltage across each capacitor is. Let's just say that again. So as the 9 volts is split across each capacitor, we can say that each capacitor holds the collective total of charge, which we've worked out there to be 27 coulombs. So each capacitor holds 27 coulombs, but the voltage will be split across them. So we can now reuse that formula again to work out the voltage across each of the capacitors. So we take the first capacitor, C1, 9 farads, so 27 coulombs divided by our 9 farads equals 3 volts. Now if we do exactly the same thing for the other 2 capacitors, so the 18 farad and the 6 farad, then we get 1.5 volts and 4.5 volts. Okay. What do we notice about all of these voltages that are across the capacitors? Well, we said that the voltage is going to be split. So if we add them all up, they should all equal our 9 volts that we've got original supply. Okay, so if we do another example here, so we've got 3 capacitors, so we're going to work out what the total capacitance is to start with. So if we pop all of that in, into our calculator, then we get a 1 over our resistance total equals 5,000, but we've not finished yet because we need to do 1 over our answer, which is our capacitance total, which is 200 times 10 to the minus 6 farads, or in other words 200 microfarads. Okay, so let's work out what the total charge is going to be, and then we can work out what the voltage across each capacitor is going to be. So in this case, 15 volts times about 200 microfarads gives us a charge of 3 times 10 to the minus 3 coulombs, or in other words, 3 millicoulombs. Okay, so let's work out what the voltage across each capacitor is going to be, and then we're done. That will be another video finished. So there we have our 3 capacitors, 250, 1500 and 3000. So I've just transferred the details down. So looking at the first one, 3 millicoulombs divided by the capacitance value of 250 microfarads. Remember that each capacitor in series is going to have a charge of 3 millicoulombs. So it's the voltage that then changes. So let's work out the answer. So there we've got the first one, 12 volts. So the voltage then across the second one, 3 millicoulombs divided by our 1500 microfarads equals 2 volts. And then we'll still work it out, but I'm going to guess it's going to be 1 volt. And yes, there it is, giving us a total of 15 volts, which is the same as a supply. Okay, that's this video done. Hope you enjoyed it. Bye.